So, are we live? Hello, hello. We are live. Hello, everyone. Welcome back to another stream. And how are you all doing? I hope the stream is going fine. Please let me know if it is not, if there is any issue, if you are finding anything, uninterruptible. How can I pop out chat? Top chat. Pop out chat. Okay. So I have a chat window over here. I can restore chat from here. Let me just put it over here. If I go and pop out chat, where is chat? If I go pop out chat, I can do this. And now live chat. Create a maybe I should send it to a different browser. Let me close this. Maybe drag it to and let me just copy this thing. Okay, this way I can see my chat and analytics of this video on my laptop. Okay, so we'll wait if few people joins, and if you are joining, please leave likes and give suggestions as well. How is this stream going and all? If audio video is perfectly fine, then we can start. And if you are new, check out my other video as well. And if you are from tech background, let's hang out on chat. If not, then we will also hang out on chat. So let's discuss what we were doing yesterday. So we created methods. If you can see, are you able to see this screen? Should I have to do this? No, I have to go to the OBS, I think, and for the screen, screen capture this thing, I have to go display and do this. If I do this, then you can see this. If I do this, you can see this. Okay, so we are here. All right. uh how is everything going, guys? Are you able to I mean, am I audible or am I clear? Let me know if the background sound is suppressing my voice. If you are just passing by, please leave a like and just say hi, and then you know you don't have to force subscribe to this channel. No worries, no problem. Just like this video that a brother is doing something, and just say hi, and it's up to you if you want to watch it or swipe. But if you are learning Rust and starting out in Rust, then please check out my channel. I am not teaching that well, but I am creating project as I'm learning as well. So maybe we can both learn. Okay, so this was we were doing modify collection. So we created this thing, resource monitor. We will call it from this thing, the process monitor that we have created. So inside the process monitor, we will handle alerts and all. You know, it's a like a start engine for this. Inside this, we will call several other functionalities. So for that, for the process part, what we have created is to check the process and all. We have created a struct called resource monitor. We implemented features. So we will, what we'll do is, we will, when we instantiate this resource monitor, we'll provide few values over here like CPU threshold and memory threshold. What it does, it is a bound value that we will provide, that hey, if any process exceeds this CPU threshold, or any process that is using some memory exceeds this memory threshold, we are going to report that process. Okay, we will log that process. So there are multiple ways to log it. You can log it on file, you can log it on terminal, you can log it on DB if you want to persist the data. For now, we will, everything will be in memory, and we'll print it on the terminal and using hashmap as an internal data structure for internal storage. It will be refreshed after every execution. So let's do, before that, let me just share this thing. Maybe we could have some people joining. So how is your day going, y'all? So let's go. All right. So we have this thing. We created this check threshold method. We returned something. Now, here is one more thing. So there are few things over here. First is modify collections. That the collection that we have created. Second is we have to clear those things as well. So let's say there is a process that is terminated, but it will be still in the hash map, right? Because we are storing that process and its usage on a hash map, so we have to clear that as well. But first let's modify sample this collection. We have a process info over here. Now what we will do, so we will try to we will enter the CPU collection, and we have a PID, that is info ID, and we will insert with first of all a new thing, because we are using vecdq, so we will use new for that, and then we will push from the back and pop from the front, like I said. So that's what we discussed on the yesterday's live. Okay, so let's do this thing. So we'll have that CPU. So we have to create this thing, right? So let's CPU this is equal to self dot CPU collection dot entry. So what will be the entry? The entry will be process info dot PID. This is the key, right? And the value will be vecdq new, and this is the entry. So it will entry, and if not found dot or insert with what will do. So let's say it says value and all. So this is the wrong thing. Oh, this not the way we do it. So we can do this. So it says expected FN1 closure from this. So we can do this thing. So we have a CPU collection over here. Uh, Maybe it's not a collection, right? We have to remove and pop from it. That's what we have to do. So maybe we call it Q, right? So now what we'll do, CPU, now that we have done an entry, so we will push from the back dot push back, and what we'll push in that, we'll put process info dot it has a CPU usage, right? So we'll do CPU usage, right? Now how can we remove this thing? We have to remove it as well. So what we'll do is we will, so as soon as new so this vecdq that we are using, it will push from the back and pop from the front. For pop from the front, what we'll do, so we need to have something here as well. How can we pop? On what basis? Okay, let's leave it for now. We will figure it out. Pop from front. maybe we could have another variable over here. You know, this variable could be a vector where we will have all the CPU usages. So we can kind of take this take it as a flag that if this variables, if this queue's length is greater than that variable, we will replace items, like we will pop from the front. So we have to maintain that sample window size length. So we can say it could be a window right, it could be vec new, and we have to define this thing here as well. Window vector of f32, right? We can do that. So here we can say if CPU q dot length is greater than cell dot window dot length, we can CPU q dot pop from front, right? So we will keep pushing on back and pop from the front. So we have no views for now. It's 3 views. I am not sure what's going. I think going this way is like going a mobile view is, because I don't think no one would be here, you know. So instead of this thing length, but we have to define some length over here, right? I think this parameter we will have to do extra step of saving kind of all the inputs. So maybe we can, instead of this, we can normally have it a small number, and on the new side what we'll do, we can also pass it from the as a new parameter. So we can say window as u size. Now that is the thing. So now instead of window dot maintaining a vector of all the CPUs, so I was thinking that maybe I can store the usages over this window thing, so that I can access that window variable instead of this CPU. But it was a wrong assumption, I guess. I think I should, maybe we can default it, but we are making it dynamic. We can default the window. This window is actually the only the length of a CPU queue. So we will say, let's say if window is 5, that means a CPU queue that we have created, that vecd queue that we are using inside the hash map, should not exceed that 5 length of 5. So this modify collection will do so. What will do? It will check for this vecd queue. If it exceeds, it will push and pop from the front back. So this vecd queue will maintain the after every process refresh, this will maintain the current 5 CPU usages for that PID. So this will be the CPU. The same goes for the memory as well. 0 views, 0 likes. Anyways, so we'll create a memory queue here as well. So we'll do self dot mem collection dot entry. We'll do process info dot PID dot or insert with and here it will do is the way we did there. It will be vec dq new. So if it has a PID, then it will make an entry, otherwise it will create a new vec dq with that. Okay, so I have this memory queue here. Now again I will check. Now what I'll do is memory queue dot pushback process info dot PID, and again I will check if memory queue dot length is greater than cell dot window. Maybe we should we have to think about this name that we have given to this. Maybe it's a bound, right? A queue bound, we can say queue bound. Let's rename it to queue bounds. Queue bound. Queue bound. Right, so memory queue dot pop front. So expected F64 and we found U32. Hey, what I'm doing? Yeah, what am I doing? I should have process info dot mem usage, right? It's F64. All right, so these modify collection, this thing okay, so this memory like this modify collection, what will do, it will check for the CPU queue and update those queues. That's what we discussed, right? So we will when the process restarts, it will update the current values by taking account of 4 previous value and 1. I'm not saying 4, I'm saying based on the queue bound. So queue bound, whatever number the queue bound has, so queue bound minus 1 will be the previous values and the queue bound will have to be replaced. So pop from the front and push from the back. So we will enter the values like that on that. So we have got 2 concurrent viewers. Guys, if you are new to the channel, leave a like and say hi. I won't force you to subscribe. Subscribe if you want to. Also let me know if everything is going fine. Okay, now that we have modified these things, right? Now let's do one thing. Now let's say a process has been terminated, but that will still be on the map, hash maps, right, on the collection. So we need to clear that as well. So we'll say public, we'll create a function for that. Public function, we'll say clear PID. For now, let's say clear PID. It will have table self process info process info. Right, it will only clear that thing. So how do we do that? How can we do? We need to check for this thing. Vec dq last in first out. It is LIFO. It makes an ideal choice for scenario like where FIFO or LIFO are required. Vec dq. So what requirement do we have? We have to pop from the front. So it will be last in first out, right? Okay, so now we have to, because will have PIDs on that, so we want to, if the process is terminated, we want to clear those things. So how we do that? Resize, remove, let's fill this one as well. Reserve, we don't want to retain mute. So we can do one some. Okay, so if I remove one, so it will remove B, right? It will give me the option of B. So the value are A and C. What it does, retains only the element specified by the predicate. In other words, remove all element E for which FFE returns false. This method operates in place. Yes. Visiting each element exactly once in the original order and preserve the order of retained element. This is good. What it does, returns none if index is out of bounds. Element at index 0 is the front of the queue. Remove and return the element at the index. Whichever end is closer to the removal point will be moved to make. Okay. So if I use remove method, so what it will do, if it is removed, then the whatever index is closer to the removed item, they all will get moved, right? Like this. So A and C. So B is removed, so C gets shifted over here. And what it does, so if I have buff dot extend one more, and if I do buff dot retain x percentile 2 equals 0, so it is checking if a number is completely divisible by this, so it will return this thing, but the preserve the order of retained element, because the element are visited exactly once in the original order. External state may be used to decide keep false true true false true 1 to 6 1 2 3 4 5 0 to 1 to 5, of course 1 to 5. Iter keep dot iter. Okay, iter dot next, so it will be 2 3 5 2 3 5. So these are false because I retained this thing, right? Next dot under and retain mute. We retain the only the element specified the predicate. In other words, remove all element E for which f mute E returns false. Okay. This method operates in place visiting each angle. Say it preserves the order, but retain mute. What's the difference? What is the difference? Only difference I can see is it's passing the Okay, it's updating this thing as well. So 125. So this is. Hmm. So it will be in place, right? So if I do retail, I'll have PIDs. So on the queue, on the collection, if I retain, back DQ, collection hash map. So I think these are we have remove retain here as well. So let's say retains only the element specified. In other words, remove all players KV, for which FKV returns false. Okay, so it will remove the entire process. The elements are visited in unsorted order. Okay, so I have 0 to map. What I'll do, map collect. So it removed those things. It has 8 elements, but so in the current environment, this operation takes O complex capacity time instead of O len, because it internally visits empty block buckets too. So if I say CPU self.cpu dot retain, I will have I'll have there this, right? This is a function impl function, so I'll have PID. So okay, one more thing, it will not be process info, it will be terminated PIDs, right? And it can be it will be a collection, maybe vector of I32, right? So we can say if collection PID, and we can say terminated PIDs dot contains PID, right? And it would be a reference over here. So so if it says or it says expected two things. So it's smash type expected, I'm not sure, let's check. Cargo build, what it says. Come on guys, 0 viewers. I think I have to switch to The main has a vector performance. Vec serve different purposes and distinct purposes. It is an unordered collection that stores unique element using hash table provide fast lookup. Okay, on the hand of the dynamic array that provide fast index access, efficient traversal due to contiguous memory space. Uniqueness, if you need to ensure all the elements are unique, a hash set. That is our primary requirement, right? The PIDs will be unique. Expected I32 found U32. Expected I32 find U32. So this thing, I hope you understand this line number 86 what you have written. We have said now we need to terminate. Now this terminated VIDs would be multiple, right? There could be multiple processes that could be terminated. So we are maintaining hash set because hash set is suitable for unique IDs that we, if there are unique IDs that we have stored, it is suitable. We'll use that. It provides fast lookup. It's unsorted. It is stored unsorted keys. So what we'll do, we will do retain. It will make remove this thing in place, and it takes a closure, and it removes everything. It removes everything which except true, if the condition is true, right? So it says PID, and we want to check if PID contain this terminated PIDs contains PID. So this it will iterate on this CPU hash collection, this hash map CPU collection, and there is a key that is PID that we have. Now we want will map like just like map in JavaScript. Then we will have we will pass a closure over here. So what it will do, it will map in this time, each time it will have a PID, right? It will iterate on this thing, and so we will check if terminated thing has this. If it's true, isn't it not? That's what we said. So what if it okay, so it is true, so it will remove that thing, and if it's false, then it will, yes. So I think we have I think we like misinterpreted. It says remove all pairs for which returns false. Okay. So it remove all pair for which k and mut b returns false. It removes all pairs. So I think if terminated PID contains PID, it will be true. Then it will retain those things. What the heck? You know what, we'll check this thing if this thing is really like working or not. Maybe let's for now let's do this for memory collection, because I'm using this method first time. So maybe, you know, so again we will have we'll pass a closure, takes 2 arguments. So we'll say terminated PIDs if it contains this PID, that is going to be iterated. So it does it like do it in place. So can we play it over here? So it says blah blah blah. So assert eq map.len is 4. So it will update the map in place, right? It will update the map in place. So if k percentile 2 is 0, what does that mean? So we have a number from 0 to 7, and we did a map over there, and we collected this item at, so first item will be 0, second will be 10, third will be 30. If I do a percentile 2, it's returning a tuple that will act as a key value pair. So for 0 it will return 0, for 1 it will return 10. So it will be something like this. So the map would be something like this. If we assume this is a template of key value, so what it does, it will return 0 for 0, 1 for 10. Ah, yes. Why is resolution so low? So why is resolution so low? I don't know. Why is the resolution so low? I don't think it should be low. Maybe I can do this thing if I do this, and if I do this, and if I do this, the thing is, if I go like this, I will have a very small ID over here, like very narrow. Now I have to change this as well. Yeah, is it okay? Is it good? Max is 360p. Oh. Max is 360p. How can I do that? Max is 360p. Output scale resolution. अच्छा, अरे यार. So I think I have got the issue. So you see, okay, you cannot see this. Let me just screen capture. I am not sure if it's due to this. So if I do go on setting, check on video, just check if you are able to. Can you see? I think this is the problem. So I changes the this ratio to 916. I think this scale resolution is 360. I have to quit the stream for that to do so. This is what's happening. So Savan, is this live is coming on shorts, or is this from the, is this you have like gone through the channel or something like that? Sorry. So this will be the hash, this will be the hash map, how it looks like: 0 for 0, 1 for 10, and 2 for 20, until it goes like 7 for 70. Now the next line says, if I retain this and I do this thing, I'm on desktop, it was recommended. Okay, it's fine, I can read the code. Okay, okay, great, great, great. Okay, okay, that's good. So I was just trying out for reach, you know. I read it somewhere that this YouTube algorithm, it promotes uh, when live goes on shorts feed. So like that. So okay, so we are here. Uh, so it will be like this, and if I use this map.retain, what it does, it says remove all pairs kv for which this returns false. Okay, so this is the function, right? This thing, closure. So if this is false, it retains it. What does that mean? It returns false. It will remove all pairs for which this returns false. So if this return false, it will remove that pair. Now this retain will iterate on this map. Let's say we are here, and what is k percentile 2? It will be 0 percentile 2. What it be? What will be the reminder? The output length is 4. Now if I do 1 percentile 10, oh sorry, 10, I think these are all. What if 2 3 6 2 5 25 0, everything is there. uh, dot collect. Okay, I don't get it now. I don't get it. I think I'm not sure if this works. So I did retain. So what I'm doing is, there will be these hash id like this, terminated processes. So if I check this, it should remove all these from those. Okay, now why I'm not removing this thing? Because first of all, it will remove, and then it will move all the other values towards the nearest possible that vacant space. So if I do this thing, it will visit only this hash map visit, it will visit hash map only once, and it also moves in place, like it updates in place. Let's see what it will do. Maybe we can print this thing, or collections, you know. We can say memory collection and all. So we'll do cpu collection and self.mem memory collection. So This is it. So this process part that we did, we have, I think for the process part what we did, we have modify collection method. We'll check the threshold and we'll push it on the warnings thing, and this warning will be returned, and this warning will be used to set the alerts. So everything will be on that thing. Now we have process monitor here, so we will call this thing from here, right? Like the resource monitor and all. So now that we have created resource monitor here, now we also need a kind of alert thing, right? That will raise a threat or issue, something like that. So we'll do that as well. Mm. Maybe we can check this thing. Maybe we can check this thing. Maybe we don't need this here. Maybe we can check this thing. Maybe we can do a println. Maybe we can say map it is. Map it is. Maybe we can check if it updates in place. It will do. Yes, because it's written in the documentation. But I want to see it will not return anything. We'll say let items is equal to this, and we'll say items. Let's see what happens. Let's run this. Map, it is empty. It is not returning anything. Let's check map. I think it is doing in place. If I do a run, I am getting 220, 00, 440, 680. Let me again copy this. It's good that we were able to reduce this thing. That what would be the hash map. Let's see how it goes. It's 550, 110, 220, 440. So this k percentile to remove 4 items. There are 8 items, 0 to 7. 224. Okay, 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 okay. Now this k is the one that is working on. That's what I was thinking. This is the thing that is checking this thing over here, right? So if I do 5 percentile 2, then it will be false. Then it will remove that value, because what retain does is it will iterate on this map and it will remove those value for which this closure is false. So as you can see, if I run this for this 5 1 2 4, so for 2 it maintained it, kept it, because if I do 2 percentile 2, it will be 0, 4 percentile to 0, 6 percentile to 0. Why it is 0? Because percentile means checking the remainder. So if I do a number percentile 2, then you have to manually divide it, and what will be the remainder? It will be act as percentile, and this slash will be the, क्या बोलते हैं उसे, क्वेश्चन जो साइड में होता है डिवाइड के ऐसे करते हैं ना वो. So if I do percentile, we have to check remainder. So if I do 5 percentile 2, remainder is 1. So that means it is false. So it will remove this thing. So 1 is removed, 2 is removed, 6 नहीं 6 तो बचेगा, 3 is removed, 7 is removed, but 4 removed, 4 left. Okay, so it is working on the key. Now let's see what we did. We did retain. We have a PID, and if I check if terminated PIDs dot contain PID, अगर terminated PIDs dot shouldn't it be false? It will remove for those that condition is false. But let's say we have a collection that has PID 1 2 3 and two process, and the two of the processes are terminated. So we have terminated PIDs as 2 and 3. So it will check first of all 1. So 1 is not there, right? So terminated dot contain should be false, or we are wrong about it. Contains asset. Contain contains दद्दा, अरे दद्दा, contains returns true if set contains a value. तो पहले तो ये false रिटर्न करेगा, तो इसने तो रिमूव कर दिया, ये तो उल्टा है. Don't you think it should be like this? Because if the ID from this hash collection, the CPU collection is not in the terminated set of IDs, then it should not be removed. If this ID is present on the terminated set of IDs, that means we have to remove this. So I think this is, so if it's false, then it will be true, and if it's true, then it will be retained. Yes, this is the ये लाइट भी चली गई. 1 hour हो गया. Okay guys, I think I have to leave. Electricity gone, weather is out, and we have been sitting here for an hour. Let me push this code. So what we have done, we did process, no, it was resource manager, right? So resource manager methods. So I have posted this thing over there. Maybe you can check this out and try to, if it's, try to improve that thing, or maybe you can check out these values over here. Let me just say it, whatever we have used today. So we have used retain method. You can check this method on the standard collections. What we have done again, we did retain, and we use some features of vecdq. we made a queue on which we did push back and pop front. So check these out on standard collection. Okay, so bye bye for now. I'll be switching to the default mode, desktop mode. uh, I can do both, but I think OBS doesn't allow multiple streams. So anyways, maybe we can wait. Let me close this thing. uh, Lofi music. As soon as I leave, people start to jump in. Screen capture, let's turn this off. Desktop audio, let's turn this off. Hmm. Can you hear the noise of fan? हाँ, राघव चड्डा भाई, हेलो, क्या हाल है? हेलो हेलो. Why for Web3 Rust is must know? Solidity. Solidity is also there. Currently I'm doing CB and want to learn Rust. What should I do? So you are doing C++ and want to learn Rust. So figure out, I mean, CPP is good. Don't go for discussions like, the guys doing CPP versus Rust. Do anything, they both will equally serve you better. But if you want to like go into the current trend, what is going on for Web3 and all, you can learn Rust. Maybe I should do a chat window here. Pop out chat. This chat I can use it here, and I can use it this here. Web3 A or AIML. So okay, let me ask you, are you a working professional or a student, or just, or switching it? What's your current tech stack? Let me keep it here. Student, okay. So one thing you can do, if you have if your surrounding is good or solid, and you have guys that are working like learning AIM and all, go for that as well. For Web3, I mean, so I mean, you must know like JavaScript, right? So if you know JavaScript, I think half of your thing is done. For Web3, I'm saying, you can learn Rust anywhere, like anytime, but make your core career first. So either do AI/ML or just JavaScript with like web development and all. अच्छा अच्छा. हम्म. आसपास का एनवायरनमेंट सॉलिड है और कोई कर रहा है कुछ भी, तो कुछ भी कर लो फिर तो सही है. अभी तो सही है. Web3 में जाओगे तो फिर पूरा ही वो करना पड़ेगा, मतलब यहाँ मतलब फुल स्टैक भी, और फिर वो जो स्मार्ट कॉन्ट्रैक्ट वगैरह वो करोगे, फिर एक लाइब्रेरी, मतलब जावास्क्रिप्ट तो करनी पड़ेगी अच्छी तरह से. बाकी ऐसे परेशान मत रहो, सब चंगा सी. तुम्हारे ग्रुप वाले क्या कर रहे हैं, मतलब जिस जिस ग्रुप में तुम हो या आसपास कॉलेज में? चलो यार, इट्स टाइम टू लीव. और so please check out these things, VecDQ, uh, that is, you can check it out everything on the Rust official standard, those documentations. So we were using these two methods, right? We were using pushback and pop front, right? As soon as the process updates, we will check if so we also have a window size over here that we called queue bound, right? So it will act as a bound for length of that queue that we created. So if it exceeds that, we will push from the back and pop from the front. So to you can check out these things. And another function that we used over here is on hash map, that is retain. So this is quite good function. It updates in place, and what it does is it will take a closure and it will remove everything for that this closure will be false. So it will remove the key value pair for which this closure value will be false, else it will be retained. Okay, so if this closure returns true, it will be retained. So in simple words, you can understand that. You can implement in all those iterables that are iterable. All right, check this out. I have pushed the code on the repo. Pull that and see if you can update or do something. All right. Thank you, everyone. Raghav, Savan, thank you very much for joining. And bye bye. See you later.